Welcome to Innovation Explorers. Experience the captivating realm of innovation, design, science, and technology. The most modern techniques in construction. In contrast to previous approaches, modern construction techniques place more value on flexibility. Modern construction techniques may entail building individual panels, slabs, or columns in an off-site factory, making them simpler to build and take down. As a result, construction companies may finish a challenging project more quickly and for less money on labor and supplies. Businesses that use production lines to generate building materials can increase the supply of homes without seeing an increase in prices, which lowers living costs for customers. Building contractors may be able to more readily track their resource use and waste thanks to these construction practices, which may also result in more sustainability. For instance, they may prioritize using renewable energy sources to power factory manufacturing lines, reducing the negative environmental impact of the building industry. By developing stock plans for prefabricated buildings, they might also find it simpler to reduce raw material waste. Contractors might more simply plan future output by just ordering resources they might utilize because each design has the same requirements. Modern construction techniques, as examples. 1. Cast-in-place foundations. Construction companies manufacture pre-cast foundations, which are structural concrete foundations that are mass-built using a reusable mold. To offer structural stability, construction specialists may subsequently join these foundations to significant supporting items such as steel columns or panels. To ensure that the structure is secure throughout its useful life, contractors and architects can also talk about the minimum load capacity of the foundations before beginning construction. Precast foundation producers can implement strict quality controls since they create precast foundations in a controlled environment, reducing the possibility that these foundations will become unstable under stress. 2. Twin wall construction. Twin wall technology includes building a new wall out of two parallel prefabricated concrete panels. Construction workers assemble these panels first, then connect them with fresh concrete or steel lattice girders to offer structural integrity. Twin walls can be used to build a variety of structures, including houses, hotels, and schools. When buying twin walls from manufacturers, contractors can specify their ideal height, width, and weight constraints. This allows them to install the walls considerably more quickly, which lowers production costs. These walls are especially good at withstanding sound and fire since they have two independent panels and a connecting area. 3. Sturdy steel edging. In heavy steel framing, steel beams are used to create a structure's framework to clearly show the sizes of upcoming levels or internal rooms. To keep the steel from weakening during intense fires, builders typically surround these frames with a layer of concrete after installation. To stop corrosion, they might also apply a zinc coating to metal beams and columns. Heavy steel framing enables the construction of huge structures quickly because contractors can plan each steel component's size, position, and load capability before placing an order. 4. Wood framing. Timber framing employs wooden components rather than steel ones and operates on the same principles that produce heavy steel frames. This technique entails joining substantial oak beams and columns to form a skeleton before attaching a layer of concrete, glass, or steel cladding to the exterior. This substance strengthens the structure's structural integrity while protecting it from corrosion and extreme temperatures. You might also add more sustainability to building projects by utilizing this technology, because it creates the building's frame from renewable raw materials. 5. Square slabs. This procedure entails producing flat concrete slabs at a factory that can be used to construct a building's walls, floors, and ceilings. You can build a series of concrete columns in the center of the room and along the walls to hold these slabs together, doing away with the requirement for steel beams. You may also add a drop panel to the top of each column so that the slab support structures bear the majority of the weight of the slab. These panels increase the column's ability to withstand stresses brought on by heavy use, increasing the column's load capacity and lifespan. 6. Panels of precast cladding. Precast cladding panels are designed during this stage of construction on a production line, frequently with glass or concrete. These panels may have a variety of features depending on where they will be placed on a structure, as manufacturers typically follow the specifications provided by contractors when creating cladding. For instance, a panel of an exterior wall might have apertures for windows or doors. Manufacturers may also incorporate steel reinforcing cages inside a panel for larger construction projects to prevent the concrete from cracking under strain. Manufacturers might add glass or multicolored metal panels to an exterior cladding panel for aesthetic reasons. 7. Raft-like bases. Single concrete slabs called raft foundations can be built immediately beneath the building and are intended to disperse pressure across a larger surface area. Steel edge beams can be used to hold a slab in place, and internal stiffening beams can be inserted to distribute pressure across and into the ground. After putting in the slab, you can cover it with insulation to prevent structural damage by controlling the temperature of the concrete. By employing this construction technique, you might make shallow soil foundations stronger while spending less money on extraction. 8. Tunnel shape. In a single production cycle, the concrete walls or slabs needed to finish a particular stage of construction are produced in tunnel form. The manufacturer then transports these parts from a factory off-site to the building site, where you can use them to create a portion of a project. To reduce any delays, the manufacturer may start creating slabs needed for the following phase of construction. Because these panels are frequently identical, you might use this technique to construct buildings with a lot of matching rooms, like hotels or student apartments. 9. Wood with cross-lamination. Wood planks from pine, spruce, or larch trees that are created and kiln-dried in a factory off-site are used to construct cross-laminated timber buildings. After stacking the boards into layers, manufacturers can vacuum press them to produce a solid hardwood panel. The manufacturer will frequently alter these panels so that they have a specific number of planks depending on the anticipated load capacity of a building. Cross-laminated timber buildings, unlike timber frames, often do without external cladding since these panels offer fire protection, soundproofing, and airtightness. Depending on the breadth of each panel, they frequently have a 30 to 90-minute fire resistance. 10. Composite concrete. Precast and in situ concrete are combined in hybrid concrete building choices to create a structure that contains the various advantages of both. You can rely on this procedure to deliver both high-quality and inexpensive components because precast concrete manufacturers produce it under regulated circumstances and according to a set formula. Instead of waiting for delivery, you may handle issues as they arise by adapting on the fly to match a project's immediate needs. Instead of depending on strict directives from top colleagues, you can decide if in situ or precast concrete may best complete a task by mixing both technologies. 11. Construction and assembly design. The process of creating standardized building blueprints that make it simple to produce and construct high-quality structures is known as designing structures for manufacture and assembly. Since contractors may replicate the same design and construction phases for numerous structures, this approach frequently concentrates on large-scale projects like developing a residential estate. Then, you may spread out repetition costs over a greater number of buildings, increasing the productive efficiency of your company. Concrete panels and support columns can be ordered in bulk from a producer of prefabricated buildings before construction begins.